Hello students, so here I am with the new series of the new chapter Wave Optics, which is presented by your physics teacher Miss Amruta Jadhav ma'am, and this contains many parts as the chapter contains many theoretical part regarding waves and light waves especially. So let's move towards what is there inside this chapter. So let's see in the next slide. So let us revise the points which are there on this slide. You have already studied in the previous years. You must have known reflection and refraction of light. What is reflection and what is refraction of light? When light incident on any surface, it either come back in same medium, or that light wave goes in another medium. So this two phenomena gives you idea about reflection and refraction of light. This you have already studied, right? Then Snell's law. You are very familiar with the Snell's law, which tells us that mu or n, which is refractive index, is nothing but the ratio of sine of incident angle to the sine of refracted angle, which is sine I upon sine r. This is nothing but Snell's law. Then electromagnetic waves, prism, and theories related to waves. Let us revise in very short. See, have a look at both the GIF, in which you can come to know very brief idea and very short idea about electromagnetic waves. What you can observe from both the GIF, there are two directions in which electric and magnetic fields or electric and magnetic waves are traveling. So first term you have to know about electromagnetic is they are having two fields. First one is electric and second one is magnetic field, and these both fields are perpendicular to each other. So from both the GIF you can come to know how the electromagnetic wave travel in any medium. This doesn't require any medium. Electromagnetic waves can travel through vacuum as well. So I hope you all have seen this both GIF and this regarding electromagnetic waves. Alright, so let's quickly move towards the next point which you have done or we have to revise is nothing but prism. You all have studied prism. You have done experiment which is related to prism. Alright, how does it look and how it exactly does? Look at this. Yes, when white beam of light is incident on prism, it get divided into 7 different colors. So this is nothing but dispersion of light. So all the theory part which is related to prism that you have done in previous years, and you have done practical as well. So you are going to remind prism formula. This is your classwork for this lecture. What is the prism's formula that you have derived in last year? Alright, try to remind that what was that. So this is about prism. Next thing what you have already learned is nature. These are the two scientists which gives many theories related to nature of light. First one is Sir Newton and second one is Huygens. So the both scientists gave theories which explains everything about light waves, and in fact wave nature, not only about light waves but about wave. So these have both have give many concepts, like the first one that we are going to see. As we all know that light is a wave, but before going towards that statement that light is wave, many theories have come across. They have discovered in many forms. One of them have discovered that light is nothing but a particle and it travels like bundle of particles. So that bundle of particle comes to us. The scientist who discovered this is Maxwell. So Maxwell says that light always comes in the form of packets, and that packets he named it as quanta. So likewise, many theories and many scientists have proven many theories related to light and to related to waves as well. So let us see some theories which are relevant to us. So from them, one of is Newton's corpuscular theory. Let's see what Newton had put forward. He says that light consists of tiny, elastic, and rigid particles. What he said, light consisting of very tiny particles which are elastic in nature and they are rigid also. So these are known as corpuscles. So that's why the theory is named as corpuscular theory. Alright, so this is the main and first point of this theory. Then these corpuscles on emission from the source of light travel in a straight line. He says that these corpuscles, that means these particles, travel in a straight line and it travels with really very high speed or with very high velocity. So this is the second assumption of Newton. Third was, when these particles fall on our retina of our eye, we get sensation of light and we can observe the image which is there in front of our eyes. So this is the third postulate, or this is the third assumption of Newton's theory. And the fourth one is nothing but different colors of the corpuscles, or the different colors of light are due to different sizes of corpuscles. Have you understood? First one is light consisting of tiny particles which are elastic and rigid in nature. These are known as corpuscles. Second, these corpuscles travel in a straight line and with the high speed. Third, when this particle falls on a retina of our eye, we can get sensation of light and we can produce, or we can sense the image which is there in front of our eye. And then we know light consisting of, or the wave consisting of, number of colors. So these colors are due to sizes of the corpuscles. As each particle or many particles are having different sizes, so the different sizes will gives you the different colors of light. And the last one is reflection and refraction of light are obviously of repulsive and attractive forces respectively. That means repulsive forces will give reflection and attractive forces will give refraction. This is as per the Newton's theory, corpuscular theory. So by looking at all this theory, there are merits as well as demerits. So what are the demerits? Let's see. Velocity of, he said that, Newton said that velocity of light in denser medium is greater than in rarer medium. But this is not at all possible, because what is a denser medium? Denser medium is the medium in which number of particles are there, so it is obstacles to travel, right? And the rarer medium is, means there is very less particles are there, so that any particle can move easily within the rarer medium. So the velocity of light in denser medium should be less than velocity of light in rarer medium, but exactly opposite Newton said. So this is the first demerit of this theory. Second is Newton unable to explain simultaneous reflection and refraction. As the light is there, light is continuously bombarding on any surface or any subject. So there is a number of times reflection and refraction occurs. But Newton failed to explain the simultaneous reflection and refraction by the corpuscular theory. And also, as we have seen all the aspects of this theory, polarization, interference have not been explained by this theory. So this is the demerit of this theory. So as this gives number of demerits, Huygens, Huygens is the second scientist which gives a theory which is worldwide known as wave theory of light, which has been discovered in 1678. So he has many assumptions related to wave theory. Again, he has many demerits also. So these are also by Huygens itself. So let's see what are the wave theory which is explained by Huygens. First is light is propagate in the form of waves. Newton said that light is in the form of particles, and Huygens discovered that light is propagated in the form of waves, and these waves emitted by the source of light and travel in straight lines. These both are same, but just major difference is that Newton consider light as particle and Huygens consider light as a wave. So he said that light is propagated in the form of waves, and that wave may be longitudinal, may be transverse wave. Second thing, he discovered that these waves emitted by the source of light and travel in straight line with the uniform speed or with the uniform velocity through the homogeneous medium. Third thing, he observed that when light enters our eye, it creates an optical expression on the retina, hence we get the sensation of light. Alright. Third is light enters our eyes and we get or we creates an optical impression on the retina and we get the sensation of light. As there are different colors of light, so that different colors are gives by the different wavelength of light waves. So this is nothing but Huygens wave theory. And the last point which he discovered, and it comes under uh, demerit, which is light wave are mechanical waves. For propagation of these waves, hypothetical medium called luminiferous ether is present everywhere. He says that there is a layer of ether in which waves of light are traveling, but later than or in some years, after some years, it is proven that there is no such medium called as luminous ether is present in the universe. So this comes under the demerit of Huygens. So let's move towards the next slide, which explains more about wave theory of Huygens. I hope you got all these points which we have learned in this slide. What was that? Light propagates in the form of waves, then it travels in a straight line with uniform velocity. When the light enters, it creates optical expressions or impressions and we get sensation of light. Different colors are due to different wavelengths of the light wave. And fifth one, as light waves are mechanical waves, it requires a medium called as ether or luminiferous ether, and which is present everywhere, which is proven by Huygens itself. So let's move towards the next slide, which tells you about merits of wave theory of light. First one, the first merit is the phenomena like reflection, refraction, polarization, and simultaneous reflection and refraction, total internal reflection, diffraction, etc. The phenomena which are really related to light or any wave are all explained by this theory, which is proposed by Huygens. He explained all the phenomena like reflection, refraction, polarization, interference, total internal reflection, diffraction. These all explained by Huygens. Second, as we have discussed, Newton said that velocity of light in denser medium is more rather than in rarer medium, which was exactly opposite. So this has been proven by Huygens, which is according to Huygens theory, the speed of light in denser medium is less than the speed of light in rarer medium. And this conclusion is in perfect agreement with the experimental findings, as the velocity or the speed of light in denser medium should be less than the speed of light in rarer medium. So this has been explained by Huygens. Then the next thing is demerits of wave theory of light. As we have seen the theory, the assumptions of this theory and merits, what we observe, what are the demerits of this theory? First one is the existence of ether or luminiferous ether. This is assumed by Huygens, was not confirmed. It is not yet confirmed that there is a layer like ether. So this is the first demerit of wave theory. Second, rectilinear propagation was not explained by this theory. Later on it is explained by or justified by Fresnel, scientist Fresnel, but in Huygens wave theory it is not been explained. Then diffraction was explained much later. Interference has been explained, but diffraction was explained very later, so that comes under the demerit of this theory. And photoelectric emission is not there inside the theory. There is no single assumption related to photoelectric emission, so it comes under the demerit of the wave theory. Okay, so this is all about Huygens wave theory, merits and demerits of that theory. Then after many years come across, then we come to know that light has a dual nature. What is meaning of dual nature? It should have two properties. That means, see, light has a dual nature. It exhibits particle nature as well as wave nature, and it is under different situation. In some situation it behaves like wave, and in some situation it behaves like particle. It gives both the nature, particle nature as well as wave nature. We are going to study wave nature in this chapter, and the particle nature, which is basically known as photons, that we are going to learn later on in future in one of the chapter of your syllabus. Alright, so let's move towards to know more about wave nature and all about waves. So first is light as a wave. So how exactly light behaves as a wave? The main thing and the main nature of it is electromagnetic waves. As we have seen in revision point, that what are the electromagnetic waves? It consists of both the fields, which is electric field and magnetic field, and both the fields are perpendicular to each other. So light also behaves like that, and you can see all the nature inside the GIF. The waves do not require any medium or material medium to propagate and can travel through vacuum also. This is the main ideal property of electromagnetic wave, in which we are saying it do not require any specific medium. It can travel through vacuum as well. Now, what about the speed of this light wave? The speed of the light in material medium, we can say it as V. It depends on refractive index of the medium. As we are saying refractive index, so it must be related to or depends on permittivity or permeability. So permittivity and permeability are the two different things. What is permittivity? Permittivity is to permit how much amount of particles should permit in a space, and permeability means what is the ability of that space to contain any particles. So we should know what is permittivity and what is permeability of any medium in which light wave or light is traveling. Now, refractive index, as we have said, what is refractive index? Refractive index is equal to ratio of speed of light in vacuum to the speed of light in medium, in which we are studying that. Okay, so what is refractive index? Again I am telling you, it is the ratio of speed of light in vacuum, we are saying it as small c, to the speed of light in medium V. This is nothing but refractive index, which can be determined or symbolized by either mu, or it can be also symbolized by n. Now what will be the value for refractive index of vacuum and air? It will be 1. For vacuum, refractive index is 1, and that of for air it can be approximately equal to 1. So this is about light as a wave. What we have studied in this slide, we said that light as a wave, and light is nothing but electromagnetic waves. Okay, and the speed of light is depends on refractive index, and directly we can say that it depends on the permeability and permittivity of the medium. Alright, so this is all about light as a wave. Now again, Huygens discovered many things, and he tried to overcome the demerits of his previous theory, which is wave theory of light, and he discovered a new theory. Let's try to move forward towards his new theory, in which there are many terms that we have to know. So let us see what are the points which includes in this theory. We'll see that points first, and then we'll go towards the main theory, which is of Huygens. So the first point which we should learn, which is primary and secondary source of light. What are the primary source of light and what are the secondary source of light? And we are going to see the example of both of them. So moving forward towards primary source, as the word itself says, primary. So these sources are the sources that emits light of their own. Primary sources are the sources that emits light by their own. They do not require any other source to emit. So these are the primary sources. But how they emit? Due to their high temperature, or due to the effect of current which is providing it in between them, or due to some chemical or nuclear reactions. So this is about primary sources. Again I am saying that primary sources are the sources emit light by their own because of their high temperature. What are the primary sources which emits light due to their high temperature? Examples will be sun and other planets. They try to emit light waves in forward direction due to their higher temperature itself, right? Then effect of current being passed through them. What will be the example of this? When the current is passing through bulb, it will give you light. That is also a primary source that causes due to current passing through that bulb. TV also, tube light also. Alright, so these are the example for primary sources. And third one is chemical or nuclear reaction. The sources which emits light due to chemical or nuclear reaction. What will be that? Firecrackers and nuclear energy generators that creates light by their own, but due to what? Nuclear reactions. That gives us light, but due to some extra terms which are related to chemical process which happens inside them. So that is primary sources. So these all are the primary sources. Now what will be the secondary sources then? Secondary sources are the sources which do not produce light of their own, but receive light from the other source and either reflect or scatter it around. So secondary waves or secondary sources are those which do not emit light by their own, but they get light from other sources and then emit or scatter it around. So these are the secondary sources. What will be the examples? Moon, other planets, and objects like humans, animals, plants, or which we see due to reflection, right? Planets also, many planets do not have their own light. They get light from sun itself and then they scattered. So this is the secondary sources of light. Moving forward towards the next point, which is water wave. In this slide we are going to observe something. Yes, observe both the GIF. After observing, what you can see over there? After observing, you can see when we drop a stone in water, what happens? We all have done this kind of experiment when we go near to water, near to river. We used to do all these things. But what physics besides that? Let us see. What happens when stone is fall, or when we drop a stone on a water surface? Waves or ripples are produces. You can see when you drop a stone, it try to create spherical waves, and they are creating ripples. So these are nothing but spherical wavefronts. Now what is wavefront? That we are going to study in next slide, but just observe both this GIF in detail. You can see this. Yes, when you drop a stone, it will create many ripples, right? So the first sphere which is there very near to the stone, it will be having same speed in first spherical or in first circle rather than in second circle. The second circle will contains speed with different, third circle will have speed of different. So all the particles which are there inside the water or water wave will try to travel or try to move in up and down positions, and these are perpendicular to the water surfaces, and the phases of waves will be different, and the phase is nothing but state of motion, right? So let's move towards to study the physical phenomena which gives you all explanation about this water waves. All right, so let's move towards the new term which is wavefront. Now, the locus of all points having the same phase. What I am saying? Same phase. Locus of all the points having same phase. What is meaning of phase? Same phase means the point, or when we are saying two particles are in phase, that is they are in a same state of motion. They are having same velocity and displacement, both are same. So these are nothing but same phase. So locus of all the points having same phase, we are going to collect all the points which are having same, which are in same phase, and the locus which is drawn is nothing but wavefront. Okay, thus the wavefront is the locus of all point where waves starting simultaneously from a single point reaching at a given instant of time. If we consider the example of stone, if we consider a stone as point O, then the waves are reaching simultaneously at the first spherical surface, then to the second spherical surface. So in first sphere, which is very near to the point O or near to stone, in that sphere all points are in the same phase. In second sphere, which are at the same distance from the stone, will having same phase, and for the third it will be in the same phase. But first and second are not in same phase, they are having different phases. Only one circumference or only one circle, and the points which are there in first circle will be in a same phase of motion. Okay, in case of water waves, wavefronts are circles centered at O. The direction of propagation of waves is perpendicular to the wavefronts, that is along the radii of the circle. The speed with which wavefront move is, so this is about wavefront. So what the basic concept is there besides that uh, falling stone in water is nothing but wavefront. Alright, and the wavefront which created are of different types. We are going to see what are the different types of wavefronts are there. Alright, now when we consider an example of water or water wave, that is 2D wave, that means it have only two directions. Now we are moving towards to see three-dimensional waves. Now which are the three-dimensional waves? Let's see. Three-dimensional waves like sound waves and light waves. What are the three-dimensional waves? The waves which emits light wave or particles in all possible direction. So that are nothing but three-dimensional waves. So as sound waves, you can see, you can hear in all possible directions. So these are the three-dimensional waves. And also light waves. Light wave give light in all possible direction, as we have seen two sources of light waves also, primary and secondary source. If we consider an example of sun, if we consider example of tube light, it emits light in all possible directions. So these examples or these waves are nothing but three-dimensional waves, and they are called as spherical waves. Alright. In these cases, the wavefronts are surfaces. In these cases, what happens? The wavefronts are the surfaces passing through all points having the same distance from the source. Alright. So let's see one example here. O is the point from which light is emitting. We are going to consider a source of light O, which is giving light in all possible direction, and it creates some circles around it. So all the circles, this is nothing but first wavefront, or this is wavefronts, first, second, third. These are the wavefronts, and which are in spherical nature. So these are the spherical in nature, or this is called as spherical wavefront. What is this then? These arrows are giving direction of the waves, propagation of the waves, direction of propagation. And next one, this is again water wave. See, this is the image of when stone is falling on water, falling in water, it creates ripples. This is the top wave. It is similar to this, right? Both are similar. So we can give this as the example of spherical wavefront as well. So let's see another one. What is spherical wavefront? Consider a point source of light O. The light waves emitted by it travel in all possible directions. When the light wave is traveling, and as it travels, so it must have some displacement, have some distance which is covered in some time. So considering velocity as small c, distance covered is t, distance covered that we are going to see, the time is small t. So by using the formula for velocity, which is distance upon time, we are getting distance is equal to velocity into time. So what is the velocity? Which is c, and what is time? Is t. So the distance which is covered by any wave is nothing but ct. And this is nothing but spherical wavefront, as we have seen in earlier slides also. Let's move towards the another type of wavefront, which is plane wavefront. Now before moving towards the plane wavefront, I want to tell you, when we consider a spherical wavefront, when we go away from that spherical wavefront, spherical lines, after going away from that, it will look like an plane surface. Like if we consider example of earth as well, earth is actually spherical in nature, but if we take one part of it, it will be a plane surface. So this is considered as plane wavefront. See, if we take a small portion of this wavefront, it will appear like plane surface, just like the surface of earth. This is called as plane waves. So first initially it is spherical. After going away from the point source, we are getting the plane surfaces. We are getting plane waves, and the wavefronts which are related to plane wave will be plane wavefronts. See, at a very large distance from the point source, the spherical wavefront is so large that a small part of it is small, almost plane. This part is known as plane wavefront. I am repeating again. At very large distance from the point source, the spherical wavefront is so large, and it is as large as it is looking like a plane surface, and so as it is called as plane wavefront. And this is the examples of both of them. Both images are the example of plane wavefront. Initially it is spherical, but moving away from that point source it will give you a plane wavefront. Initially it is a spherical, right? Then the next term and very important point is wave normal and a ray of light. What is wave normal? As the word normal is there, it should be some perpendicular. Now what perpendicular should be there? You can have a look at the diagram. There is a spherical wavefronts are there. Light is traveling in circular form, that means spherical is there, spherical wavefront is there. See, the perpendicular which is drawn to surface of wavefront at any point is called as wave normal. When we draw a perpendicular to the surface of wavefront at any point, it will give you wave normal, and this is nothing but the direction of propagation of light waves. In when we have studied the spherical wavefront in this first diagram, they have given the diagram of rays also. When we are considering a sphere, you can have a look again. You can have a look at the same here. This sphere, spherical wavefront, and this is perpendicular. So this is nothing but the wave normal. So in the diagram we have seen all of these things. Alright, so let us move towards this point, wave normal and a ray of light. What we have said, a perpendicular drawn to the surface of wavefront at any point is called as wave normal. So this is nothing but wave normal, right? Now what is ray of light? The direction in which light wave travels is called as ray of light. A wave normal is same as ray of light. We are considering wave normal as a ray of light. Both are the same, alright? Because as we are drawing a normal to that surface, as it giving the direction, so as it is the line which is giving direction is nothing but the ray. It must be ray of light, right? So this is nothing but ray of light. So finally we are moving towards our final point and very important point of this chapter, which is Huygens principle. What does it exactly gives? Huygens principle. He assumed that, what Huygens assumed? He assumed that light to be a wave similar to mechanical waves like water waves, sound waves and light waves, right? Just the only one demerit from his theory was the point which contains ether, right? Accordingly, the particle of ether oscillates due to propagation of light wave, but it is not proven. So moving towards his new invention, and what he discovered is this: each point on wavefront, as we have seen wavefront, two types of wavefront as well, each point on the wavefront acts as a secondary source of light. Many things are important in this principle. Try to concentrate on this slide. I will underline what are the important things. Each point on the wavefront acts as a secondary source of light, emitting secondary light waves called as wavelets. This is the first. What he said, that each point on a wavefront acts as a secondary source of light and emitting secondary light waves, and these are called as wavelets. He is letting the waves to move forward, so wavelets is there. So it is called as wavelets in all direction, which travels with the speed of light in the medium. The new wavefront can be obtained by taking envelope of these secondary wavelets traveling in forward direction and is thus the envelope of secondary wavelets in forward direction. The wavelets traveling in backward direction are ineffective. Okay, I'll try to explain this principle. What he said, that if we consider a wavefront, each point on the wavefront will act as a secondary source of light, and it will try to emit all the light waves in all possible direction in only forward direction, because backward direction is ineffective according to him. So as it providing a light wave to let move in forward direction, so this term is known as wavelets. What are the wavelets? The points or the light waves which behaves like secondary light source. So these are the wavelets. Now the second thing which you discover and which is tells us that the new wavefront which is given by the secondary wavelets can be obtained by taking the envelope of this secondary wavelets. We are going to take another locus on which all the points are in the same phase, and we are going to consider this all as a wavefront. So this will be envelope of the secondary wavelets, and these are traveling in forward direction. So this is all about the Huygens principle. Again I will tell you, each point on the wavefront will behave like a secondary source. It will try to emit light waves in all possible directions. So these are called as wavelets. As the second sources which are creating light waves, we are going to take the envelope of this secondary wavelets, and these are traveling in forward directions, and these are effective only in forward direction and ineffective in backward direction. So this is all about the Huygens principle. So I am going to stop the lecture. I am just going to tell you what points we have covered in this slide. Okay, I hope you have got all the things which are there inside this slide and there inside the part 1. Okay, the first thing which we have seen is wave nature, theories of waves. Many theories we have seen. Corpuscular theory we have seen, wave theory we have seen, and then we come across the Huygens principle, in which wavefront is the concept. Yes, the third point is wavefront. Then the wavefronts are of two types, actually three types. We haven't seen the third type. First type is spherical wavefront, second type is plane wavefront, and third type is cylindrical wavefront as well, but we have not seen that. Okay, moving towards next point, which is wave normal, which is nothing but a ray of light. Okay, and the last point is Huygens principle that we have seen. You have to learn, you have to by heart this principle, because principles, laws have to be learned and have to write as it is. You cannot change its wording. You can change the wordings of explanation, but you cannot change the wordings of principles. So you have to learn this Huygens principle as it is, so as to get the full marks. Alright, so this is all about part 1 of our series. Thank you so much for watching the video, and thank you. Do comment if you have any query and attempt the test after watching this video. Okay.